In 1974, researchers directed a radio telescope toward the stellar grouping M13, dispatching the initial purposeful signal from humankind to extraterrestrial beings. This act held symbolic significance. The cluster M13 lies 25,000 light-years distant, yet unforeseen were the nearer entities possibly tuning into our unintended emissions. For 123 years, people have unwittingly conversed with the cosmos. Broadcasts of baseball matches, sitcom episodes relayed outward, radar signals aimed at planets, all seeping into the void, forming a growing sphere of earthly discourse. Beginning in 2017, enigmatic visitors from beyond our system have appeared more often. Oumuamua Boris, now 3I Atlas, each odder than its predecessor. Suppose our 100 years of radio emissions have at last found an audience. Suppose these intruders represent not mere cosmic occurrences, but the cosmos acknowledging our outreach. Remain through the conclusion to learn how our stellar dialogues could be eliciting responses. Get ready. Part 1 commences, calling out into the void. Over 100 years, humankind has addressed the stars, not deliberately in every instance, yet addressed them all the same. AM stations sending baseball play-by-plays into the evening, TV antennas projecting comedy series upward, radar bursts targeted at Venus or drifting space rocks. Each element leaks outward at light's pace, building a ballooning zone of mortal babble that reaches about 130 light-years from our world. This forms our radio envelope, a ball of radio waves proclaiming our existence to any attentive ear. Yet, our outreach into the shadows divides into two categories. One involves mishaps, radio spillage, the unplanned overflow from a society that mastered wave control prior to mastering silence. The other category consists of intentional dispatches, akin to notes cast into an immense sea. During 1972 and 1973, Pioneer 10 and 11 took flight bearing golden plarks, illustrating bare humans and indicating our galactic position. Hopeful, maybe overly trusting. Those plarks displayed the hydrogen atom's spin-flip shift, offering a common measure for time and length. They outlined our planetary arrangement, highlighting Earth as the third body orbiting a mid-sized sun. In a daring move, they featured pictures of a male and female figure next to the probe for proportion, their arms lifted in a gesture intended as a global hello. The Voyager Golden Records came next in 1977, an even grander effort. Chuck Bry's Johnny B. Good whirling amid whale calls and salutations in 55 tongues through the interstellar expanse. Those discs held 116 visuals depicting Earth's varied life and customs, along with math and physics basics, the planetary layout, DNA's form, bodily structures, reproduction, delivery, kinship units, buildings, artwork, and tunes. Carl Shawn described it as an address to the stars. Some labeled it stellar scribbling. But the sharpest broadcast originated from Arecibo in 1974. Frank Drake, along with his group, pointed the massive reflector at the ball-shaped cluster M13, sending precisely 1679 data bits. The reason for 1679, it multiplies as 23 times 73, both prime numbers. A recipient would spot this numeric clue and form the bits into a grid shape. The content would emerge as a dotted sketch displaying our counting method, DNA's makeup, a basic human outline, and our planetary setup with Earth noted. The broadcast endured precisely 3 minutes, drawing almost 1,000,000 watts of strength. In that short span, Arecibo shone as the strongest radio emitter in our nearby stellar region. The wave sped to M13 at light speed, bearing our debut planned exchange across the stars. It served more as a ritual. M13 sits 25,000 light-years off. By the time our message arrives, human societies on distant worlds might have emerged and collapsed through countless cycles by now. Yet we dispatch the message regardless, for the simple gesture of outreach can carry more weight than any hope of response. Back in 1959, Yeppe Kone and Philip Morrison laid out the reasoning clearly. In their piece for Nature, they contended that electromagnetic radio signals offered the ideal pathway for exchanges spanning the stars. They highlighted the water hole, a serene stretch in the frequency band from 142 to 1. 66 GHz flanked by the spectral signatures of hydrogen and the hydroxyl radical OH essential components for forming water. Any advanced society versed in basic science would instinctively tune into that spot. The hydrogen emission at 1/420. 4 MHz stood out as especially crucial. That precise wavelength captures the shift in energy as an electron in a hydrogen atom switches from aligning parallel to antiparallel with the proton's magnetic influence. As the cosmos's most plentiful substance, hydrogen embodies its core atomic shift. For extraterrestrial beings seeking a shared protocol for contact, this elemental marker would stand as the natural pick. Decades of our detection efforts have clung to this principle. Facilities like the SETI Institute deployed detectors focused on the hydrogen frequency. Breakthrough. LISTEN keeps watch over vast numbers of stars on various wavelengths. The approach holds firm. To reach voices across vast cosmic gaps, one transmits in the galaxy's inherent hush. Still, experience with our signals reveals a stark truth. They fade into silence all too easily. The bulk of our TV and radio broadcasts, after breaking free from our planet's air, blend seamlessly into the cosmic static just beyond a handful of light years. The rule of inverse squares shows no mercy. As separation doubles, intensity drops to a quarter. Just a few of our strongest emissions endure the trek to neighboring suns. Radar setups for planetary study, such as Arecibo's S-band emitter or Goldstone's X-band setup, pulse with enough force to register over star-spanning voids. Meant for charting rocks and worlds, these tools unwittingly act as beacons. With each turn of Earth, their sweeps carve paths through the heavens, leaving a unique imprint that no watchful alien society could mistake in our stellar neighborhood. Humanity's grandest bid for interstellar linkage comes through the Deep Space Network. Vast antenna arrays, 3 in total, dot the landscape, one amid California's Mojave Desert, another close to Madrid in Spain, and a third beyond Canberra in Australia. They sustain unbroken links to our mechanical probes roaming the solar realms. Spanning up to 70 meters in width, these reflectors possess the sensitivity to pick up faint whispers from the fringes of explored territory, as if aimed at some foreign observatory. To outside eyes, our radio landscape would appear oddly patterned. Slender signals flicker in and out with our world's spin. The orderly bursts from FM broadcasts and TV stations fill their allotted spectral niches. Sharp radar bursts rake the firmament in steady rhythms. Everything huddles near a lone azure orb, buzzing with unusual vigor across the airwaves. The International Telecommunication Union safeguards select bands for astronomical listening, acknowledging the need for pristine channels to catch the stars' murmurs. Protected areas near key telescopes curb ground-based broadcasts that could swamp delicate instruments. In West Virginia, the National Radio Quiet Zone covers 13,000 square miles, forging a haven of radio stillness encircling the Green Bank Observatory. The United Nations Office for Outer Space Affairs oversees global protocols for space endeavors. Even if they've yet to handle any cosmic correspondence, its scope emphasizes nonviolent pursuits beyond our world. However, the guidelines presume involvement from earthbound players bound by our laws. Rarely has anyone pondered the reach of global treaties toward arrivals from remote suns. Such questions expose a core divide within the SETI field. Traditional SETI passive observation has long defined the essence of this pursuit, a quiet act of tuning in. The Breakthrough Listen initiative sifts through petabytes of information gathered by radio observatories across the globe, hunting for anomalies that stand out from the norm. In the northern reaches of California, the SETI Institute manages the Allen Telescope Array. 42 antennas collaborate seamlessly, probing the heavens for signs of engineered emissions. Yet a contrasting approach exists in active SETI, also known as METI, which stands for Messaging Extraterrestrial Intelligence. Advocates in this group push for broadcasting deliberate, potent signals outward into the cosmos. They contend that mere eavesdropping by all parties ensures perpetual silence. Perhaps the Milky Way teems with societies, each holding back in hushed anticipation for another to break the ice. Such ideas provoke thorny dilemmas. Regulations on exports view potent broadcasting devices as prospective armaments. Communication setups suited for reaching across stars might, in theory, serve hostile intents. Beyond that lies a profound ethical quandary. By what authority do we presume to represent our planet? Is it fitting for a handful of researchers and technicians to decide on matters of such gravity? Past incidents of mistaken detections foster wariness among practitioners. Back in 1967, Jocelyn Bell Bernal picked up a strikingly rhythmic radio emission originating beyond our world. Pulses arrived every ping, 37 seconds, unwavering like the tick of an atomic timepiece. Members of the Cambridge group momentarily pondered if this hinted at otherworldly minds. They dubbed it LGM-1, shorthand for Little Green Men 1. The finders mulled over the chance they were beholding proof of a stellar society. In reality, it proved to be the inaugural identified pulsar, a rotating neutron star beaming radio waves that grazed our planet akin to a beacon sweep. That exactitude stemmed not from crafted intellect. Rather, it arose from natural laws stretched to their boundaries, compressing substance to the brink. Neutron stars cram solar masses into orbs just 20 kilometers wide. Their magnetism dwarfs Earth's by trillions of fold. Swift rotations in these entities yield stellar lighthouses pulsing with uncanny steadiness. Another renowned case is the WOW signal, captured by the Big Ear Radio Observatory in 1977. Over 72 seconds, the instrument logged a potent focused emission close to the hydrogen frequency. Its intensity so impressed astronomer Jerry Iman that he scrawled "Wow" beside the data readout. This burst displayed traits long anticipated by SETI experts for non-natural origins: tight spectral width, robust strength, and attunement to hydrogen's inherent broadcast band. Even after years of targeted scans, it has eluded recapture. Explanations multiply. Maybe a singular dispatch from extraterrestrials, or an earthly echo bounced from orbital junk, or an obscure cosmic event. This anomaly endures as a prime enigma in SETI annals, yet it also warns of the hurdles in separating deliberate transmissions from the universe's static. Such episodes impart crucial insights. Bold assertions demand robust proof. Prospective detections need replication, confirmation from varied sites, and clear non-terrestrial sourcing. Practitioners have forged strict guidelines for vetting and publicizing to avert hoaxes igniting widespread alarm or eroding trust in science. The Rio scale, akin to the Richter scale for seismic events, offers a metric to gauge the weight of prospective SETI finds. Scores spanning 0 to 10 weigh the emission's seeming crafted quality alongside its prospective sway on society. Typical prospects land at 1 to 3. Intriguing yet unproven. A validated beacon from a sophisticated off-world culture might hit 8 or 9, marking a pinnacle revelation for humanity. Mass media has molded our preconceptions as well. Starting with Orson Welles' rendition of War of the Worlds, aired in 1938, through contemporary movies such as Contact and Arrival. Society has practiced scenarios of initial encounters. Tales spun from imagination shape our views on the quest for extraterrestrial intelligence, stirring expectations and anxieties that often diverge from actual prospects. Popular sci-fi depictions typically depict encounters with otherworldly beings as sudden and theatrical vast vessels materializing above our planet, or potent transmissions reshaping society in an instant. In contrast, genuine SETI efforts emphasize quieter prospects, weak emissions from far-off societies, remnants hinting at past interstellar explorers, or engineered relics wandering the voids between stars. Yet, the act of calling out into the void carries its own introspection. Sooner or later, doubts arise about whether echoes will return. For more than 100 years, humanity has been emitting signals outward. Our expanding sphere of radio waves propagates the essence of our culture toward proximate stellar neighbors. Annually, this radiant footprint extends to fresh star systems, signaling our existence to any watchful entities. Should any distant intelligence have tuned in, catching our early TV signals, radar echoes, or intentional dispatches, they've enjoyed ample years to craft a reply. The underlying principles of propagation are basic. Emissions propagate at the pace of light, Thus, replies from close stellar sources could reach us mere decades after our opening salvos. What truly haunts SETI researchers in the wee hours isn't the existence of cosmic minds elsewhere. Probabilistic models imply our galaxy brims with such societies. The real puzzle, deceptively basic yet profoundly disquieting, boils down to this. Suppose a response actually arrives. Part 2. The inaugural reply evening and the emergence of 3 Atlas. On July 1, 2025, the Atlas facility in Rio Hurtado, Chile, performed its routine duty, surveying the southern heavens for anomalies that zipped along too swiftly or gleamed with excess intensity. The asteroid terrestrial impact. Last alert system runs 4 automated outposts, their lenses snapping shots relentlessly under cover of darkness to compile an inventory of every potential Earth-endangering boulder. Atlas embodies the pinnacle of hands-off celestial monitoring. Every site snaps photos at intervals of 30 seconds, sweeping vast celestial expanses per frame. Advanced software sifts through successive captures, highlighting items that shift relative to fixed stars or exhibit odd luminosity shifts. Its core purpose, spotting dangerous near-Earth objects far enough in advance spanning weeks or months to allow defensive measures against heavenly perils. Precisely at UTC, the alert mechanism in Atlas IV pinpointed an oddity within the microscopium grouping, a luminous speck traversing the starry field at close to 3 arcseconds each hour. Swifter than any belt fragment ought to travel from such remoteness. This entity had already penetrated Jupiter's orbital path and was hurtling toward the Sun's core domains. Computational routines promptly initiated estimates of basic flight paths. The entity's location and pace pointed to a course wholly alien to known solar debris logs. Early projections revealed an orbital eccentricity exceeding unity, the hallmark of a path free from gravitational tether, no mere ensnared rubble from the main belt, instead, an intruder originating beyond our stellar boundaries. In under 6 hours, validations arrived via Pan-STARRS atop Hawaii and the Zwicky Transient Facility on California's coast. The intruder proved authentic, blisteringly quick, and on a route defying any native solar body. 3 distinct monitoring networks had logged this erratic traveler, ruling out glitches in gear or stray particle strikes on sensors. Based in Cambridge, Massachusetts, the Minor Planet Center acts as the global hub for validating finds of minor worlds and icy wanderers. Its processors crunch the intruder's path data, yielding a disconcerting verdict. Eccentricity measuring 1.47, signaling a hyperbolic surplus speed of roughly 15 kilometers. No tie to our sun's domain. Purely an interloper from the stars. An interstellar wanderer traced a path of hyperbolic excess, propelling it across the bounds of our solar realm before hurtling onward into the vast galactic expanse. This find sparked urgent scrutiny from premier global facilities. In Chile, the European Southern Observatory deployed its immense telescope, coordinating its 8 2-meter mirrors for unified surveillance of the intruder. Hawaii's Keck Observatory contributed to the effort, employing adaptive optics to secure diffraction-limited views. Even the Hubble Space Telescope earned priority slots to scrutinize this uncommon extrastellar guest. Official labeling arrived swiftly. 3I Atlas. The 3I prefix signified its status as the third verified interstellar interloper, succeeding 1I Oumuamua from 2017 and 2I Borisov in 2019. The Atlas ending paid tribute to the detecting site, upholding the custom of acknowledging the initial spotter of noteworthy celestial entities. Yet 3I Atlas diverged sharply from those earlier arrivals, larger in scale, more luminous in glow, and pursuing a course that defied standard physical principles. Oumuamua had appeared as a spinning cigar-shaped boulder, comparable in dimensions to an urban thoroughfare segment. Its brightness fluctuations exposed an outsized form, with elongation surpassing 5-fold its breadth, and perhaps extending far beyond. Sunlight bounced off it in peculiar fashions, displaying traits alien to familiar asteroids or comets. The greatest enigma lay in hints of extra-gravitational propulsion subtle thrusts beyond the sole influence of solar pull. A group, led by Marco Micheli at the European Space Agency, meticulously dissected Oumuamua's path, drawing on Hubble imagery alongside terrestrial telescope records. Their publication in Nature during 2018 outlined consistent shifts away from unadulterated orbital pull. These boosts proved modest, yet reliably measurable, around 5-10-6 Mensidu, some 10,000-fold fainter than gravity at Earth's surface, though indisputably present. Certain experts floated ideas of comet-style venting absent any observable plume. Such forces could stem from vaporizing frost generating minute thruster-like impulses as the body warmed in solar proximity. Alternative theories ventured into stranger territory, perhaps a shard of extraterrestrial solar sail driven by starlight pressure or remnants of a shattered comet bearing odd makeup. In contrast, 2I Borisov acted with greater familiarity. It embodied a true comet originating beyond our system, adorned with a hazy envelope and a clear tail, detectable from earthly scopes. Its behavior aligned flawlessly with established orbital lore, comforting researchers that typical interstellar drifters remain ordinary phenomena, albeit scarce. Borisov's makeup closely resembled native solar comets, hydration ice, frozen carbon monoxide, and molecular organics turning to gas upon nearing the sun. 3 Atlas occupied a midpoint amid these poles, rendering it both captivating for inquiry and faintly disconcerting. Initial brightness measurements uncovered fluctuation patterns absent from standard archives. Typical asteroids whirl in disorderly spins, their luminosity shifting as varied surfaces intercept solar rays. Such erratic motion arises from past crashes that impart intricate tumbling dynamics. However, 3I Atlas displayed near-periodic rhythms, steady pulses implying a disciplined, nearly engineered spin. Dominant fluctuations cycled every roughly 3 hours. Nested inside this rhythm lurked finer ripples, hinting at elaborate shape or terrain details. Most captivatingly, these intervals held remarkably steady over multi-week monitoring. Ordinary spinners usually exhibit drift in their timings as rotational axes shift amid diverse influences. Yet 3 Atlas preserved exact cadence, evoking an impression of deliberate orientation control. Spectral scans via the European Southern Observatory unveiled further riddles. Despite its solar near-miss, the entity betrayed subdued venting traces. Conventional comets sprout sharp spectral hallmarks, glowing bands from evaporating water. The presence of carbon monoxide alongside various other volatile substances stood out. Yet, the spectral profile from 3I's appeared remarkably pristine, chiefly featuring sunlight bounced back with just subtle hints of gaseous outflows. No established category of asteroid or comet aligned with this reflectance signature. The hues deviated sharply, excessively crimson compared to standard silicate compositions and overly abundant in organic elements for commonplace bodies. Indicators of absorption pointed toward exterior substances that could be uncommon or perhaps deliberately refined. Certain experts in spectroscopy proposed unconventional carbon-based molecules, or maybe thin metallic layers capable of yielding these peculiar visual traits. Specialists in radio detection at Goldstone attempted to illuminate the entity using their radar setup for planetary bodies. The 70-meter antenna within the Deep Space Network broadcasted robust bursts at 856 GHz, matching the wavelength employed for charting Venus and monitoring asteroids close to Earth. The echoed response proved faint, yet captivating. Rather than the jagged, diffused rebound common to an asteroid's uneven terrain, 3I Atlas yielded mirror-smooth glints, even planar echoes implying polished facets aligned with exact orientations. Its radar cross-section fell short of predictions based on its visible luminosity, pointing to either atypical makeup or form that redirected radio emissions in unforeseen directions. As the James Webb Space Telescope directed its infrared gaze at 3II, the findings grew increasingly bizarre. The exceptional acuity of JWST uncovered heat characteristics resistant to straightforward interpretation. The thermal profile of the body suggested a low albedo. It soaked up the bulk of incident solar rays, in line with a shadowy exterior potentially laden with organics. However, nestled amid that radiant warmth lay intense specular peaks, slender rays of infrared bounce that flickered into view and vanished with the body's spin. Such a configuration aligned with layered films or designed veneers, able to redirect illumination at chosen bands while devouring the rest. Rarely did innate substances display this kind of targeted light behavior. Terrestrial facilities in Chile synchronized their scrutiny, leveraging the southern hemisphere's optimal sight lines. Visibility of the body would persist until December 2025, offering researchers a vital interval to examine the third wanderer from beyond our solar system. The Atacama Large Millimeter Array contributed to the effort, probing for molecular outflows that could disclose the body's makeup and inner makeup. This find sparked profound scholarly fascination, though outreach to the public remained deliberately restrained. Lessons from the Oumuamua episode had taught space organizations how unchecked ideas of extraterrestrial artifacts could overshadow media before thorough vetting concluded. Official statements highlighted the body's cosmic provenance and odd attributes, steering clear of hasty guesses regarding manufactured beginnings. Still, the radio data shifted intrigue among scientists toward near concern. On July 15th, a fortnight post-initial sighting, arrays of radio dishes across various locations picked up a dim, tight-band, steady tone, seemingly traveling alongside 3I Atlas. The wavelength hovered around 400 MHz, a touch displaced from the hydrogen emission, radio astronomy's premier marker and a staple in SETI hunts. Confirmations arrived at once from the Very Large Array in New Mexico, the Green Bank Telescope in West Virginia, and FAST in China. Verification spanning continents ruled out nearby disruptions or equipment glitches. The emission proved genuine. Its source lay beyond Earth, and it seemed to emanate from our third interstellar guest. In radio astronomy, frequency clutter poses endless trouble. Broadcasts from satellites, cellular masts, and even kitchen appliances can taint data with false positives resembling celestial events. Yet this emission cleared all authenticity checks, for the notion of an off-world source lingered in the air. Detection occurred solely when receivers aligned directly at 3I Atlas. Frequency alterations via Doppler effect matched precisely with the entity's path through the cosmos. Signal strength and spectral properties remained uniform over repeated viewings. At first, there was no clear patterning in the emission, just a pure, slim-band hum that shifted tones as 3I Atlas traversed its route. This Doppler evidence proved the emitter accompanied the body rather than lingering fixed amid distant stars. Remarkable steadiness in the waves hinted at an advanced timing device synced to atomic precision benchmarks. Experts in the field responded with measured doubt, recalling that bold assertions demand ironclad proof. While earthly events like spinning stars, amplified light bursts, or charged gas clashes in magnetic fields around worlds can yield tight radio bursts, the chosen band raised eyebrows. What reason could there be for transmitting near the neutral hydrogen wavelength if not to catch the ear of skywatchers tuned to that spot? Yet, as verifications flooded from global scopes, a troubling idea took shape. 3I Atlas was sending out a deliberate beacon. Media outlets naturally showed no such caution. Even with tight secrecy from state bodies, word of the radio find spread like wildfire in mere hours. Online platforms buzzed with guesses, phrases like "the reply" shot to the top of Twitter feeds, clips on YouTube boasting headers such as "proof" or "aliens answer our call," racked up millions of watches. The celestial form, dubbed 3I Atlas by pros, picked up a slew of casual tags: the messenger, the reply, visitor 1. Hobbyists with radios across the globe started scanning the hydrogen band, eager to pick up the ping on their own. Affordable, user-friendly software radios opened the door for countless enthusiasts to join the watch. Radio Sky Science's open access ensured no elite group could bury or steer the breakthrough. Researchers strove to keep balance. Perhaps the pulse stemmed from some rare gas event or odd clash of the intruder with sun-wind particles. Comet radio glows had precedence, but usually at other bands with distinct traits. The hydrogen spot could well be chance, not design. Official space outfits released guarded updates, stressing the early-stage data. NASA bulletins clung to basics: path details, rough dimensions, orbit shifts, signal spot. They shunned talk of crafted beginnings, even if private notes suggested otherwise. In private huddles, ThreatWatch teams grappled with tough queries on crafty chatting intruders. The Defense Hub for Space Rocks, born from the 2013 Chelyabinsk meteor strike, had zeroed in on wild rocks and ice balls, posing crash risks to our planet. Yet 3i Atlas signaled a fresh worry class: how to gauge danger from something possibly guided by smarts. Officialdom clung to 3i Atlas, but folks' fancy leaned toward punchier monikers. The reply tapped into our shared mindset. For more than 100 years, we'd shouted into the void via radio waves, TV signals, aimed dispatches like the Arecibo message. Maybe, at last, a voice shouted back. The foundation for the ensuing saga was straightforward yet deep. Humanity faced, for the initial chapter in its tale, probing whether a star roamer was mere fluke of the universe, or instead, a retort, an echo to our cosmic shouts. All scrutiny, all gauging, all probing would unfold under strict scholarly rigor. Consider the benchmarks, yet directed by one central inquiry. Suppose 3i Atlas caught our signals and chose to respond. Should this hold, it would utterly transform all notions regarding humanity's position amid the cosmos. Solitude was an illusion, an entity was attuned. Moreover, it had journeyed through the Milky Way to signal that our transmissions resonated amid the celestial expanse. Yet initially, the task lay in discerning if this constituted a remarkable cosmic occurrence or an altogether distinct entity. One that traversed the vast emptiness between stars expressly to reach us, bearing a communication we were just starting to decipher. Part 3. An influx of arrivals far from isolated. 3 Atlas stood not solitary. Mere 3 weeks following the first sighting, robotic celestial scans started highlighting further swift entities on hyperbolic paths. This spotting trend hinted at an event without parallel in astronomical chronicles. Numerous extrasolar intruders manifesting over mere months. Their emergence displayed synchronization that defied all preconceptions of haphazard stellar happenings. 4i surfaced within records from the Catalina Sky Survey dated July 22, 2025. The Linear Near-Earth Asteroid Research Program identified 5a just 2 days afterward. Come August, hobbyist stargazers using home setups added to an expanding inventory of extrasolar intruders. Such findings gained confirmation from expert facilities wielding scopes priced in the hundreds of millions of dollars. No mere stray stellar remnants flung by remote stellar upheavals. These entities exhibited traits growing increasingly alarming per fresh sighting. To begin, their entry paths. Examination of extrasolar entity paths ought to reveal scattered arrivals from every angle as they wander via the Milky Way's pull. Yet this cluster displayed mild synchronization, defying norms by vast degrees. Their paths funneled from a sky sector spanning about 15, focused upon Lyra, like projectiles dispatched from one broad spatial zone. Dr. Alan Fitzsimmons of Queen's University Belfast directed the quantitative review. His group determined the odds of such alignment happening randomly at roughly 1 in 50 million, far under the bar for asserting notable relevance in astronomy's other domains. An agency had directed these entities toward our star system with accuracy implying intellect and sophisticated engineering. Even more disconcerting, their perihelia, their sun-nearest points, gathered in a tight band from 0. 8 to 1. 2 astronomical units. They navigated precisely Earth's path region, slicing via the zone our world circles the sun. Such pinpoint aiming was phenomenal, implying awareness of our system's layout and perhaps our globe's exact spot. The chances of wild extrasolar entities chancing into Earth's path zone proved minuscule. These arrivals were steered our way, their courses plotted to heighten viewing chances via ground scopes while keeping clear of our world. Photometric studies uncovered further motifs defying organic origins. 3i Atlas seemed a slender spinning plate under regulated orientation. Later entities displayed stranger forms. 4i's luminosity shifts implied a slender form with a ratio nearing 20 to 1, slimmer and more elongated than any solar system native. Photometric records showed 4i flipping tip over tip every about 32 hours. Yet the flipping lacked the disorder of a smashed natural piece. The spin bore signs of guided movement, as though onboard systems were adjusting the alignment of these entities to best capture sunlight for power generation or to align with signaling alignments. The fifth one, 5I, appeared as a spinning fragment. Its brightness profile displayed intricate fluctuations indicating a structure that was somewhat shattered. Examination through spectroscopy uncovered odd traits on its exterior. Substances possibly riddled with voids or somewhat empty inside, yielding reflective qualities distinct from those of typical asteroids or comets. Another, tinier entity labeled 6I generated illumination patterns matching what experts liken to a sliver, an element slender and pliable, undulating while spinning in the void. Shifts in luminosity pointed to a flat membrane form, potentially warping from heat pressures or deliberately altering its form. Such forms contradicted standard principles of celestial mechanics for asteroids. Debris from impacts in nature adheres to expected behaviors tied to substance durability and collision forces. Solid stone forms usually shatter into near-round pieces. Frozen comet pieces split at inherent fault lines, yet delicate layer forms, membranes, flats, arrays could act just as the data indicated. The consequences stirred discomfort. Everyday cosmic mechanisms seldom yield items with drastic proportions and regulated spin behaviors. Yet, engineered devices built for journeys between stars could exhibit exactly these traits, particularly when crafted for least weight and greatest expanse. Arrays of radio dishes across the globe synchronized their scans, following every entity nearing its closest solar pass. Findings sketched a scene upending all preconceptions of cosmic intruders from afar. Every entity emitted tight-band radio waves close to the hydrogen frequency, yet none matched precisely. Variations appeared in modulation styles, in frequency shifts, and in time-based features. These radio marks hinted at a spread-out network for messaging, not random outputs. 3I Atlas held a constant hum at 424 MHz, 4I sent out at 426 MHz featuring gentle shifts in strength. 5I sent short pulses over various bands in the waterhole range. 6I generated intricate transmissions appearing to hold coded data through shifts in pitch and rhythm. The range of transmissions eliminated basic accounts rooted in natural events. Interactions with ionized gas or immersions would display uniform traits among entities sharing makeup and paths. Yet these arrivals transmitted as if part of an organized armada, every piece adding to a broader exchange. Dr. Elena Vasquez from the Arecibo Observatory put forward the idea later called the staging theory. These entities did not show up by chance or as remnants from one massive disaster. Instead, they formed a deliberate lineup aimed at boosting visibility and backups, all while cutting chances of their signal being ignored or rejected. From a design viewpoint, the staging method held logic. Should one aim to reach out to a freshly spotted advanced society, dispatching several couriers would guarantee delivery, despite some going unnoticed or misread. The diverse features of each entity offered varied proofs of crafted beginnings, rendering it harder to wave off the whole group as mere nature. Timing links proved just as compelling. As experts pieced together the departure slots needed for each to reach its noted arrival, factoring speeds across stars at 10 to 20 of light pace, links emerged to humanity's transmission past too exact for accident. 3I Atlas, sent from a stellar setup about 50 light-years off, would have set out near 1975, during the height of strong TV signal eras, alongside the initial extensive radar operations targeting planets. The fourth element in 3I's chronology coincided with the dawn of the space era and the erection of massive radar bases for defense purposes. The fifth aligned with the era when satellite-based commercial messaging started saturating our planet's frequency bands with organized transmissions. One might imagine an entity tuning into the expanding broadcast footprint of our species and replying in kind step by step. Every interstellar craft dispatched seemed to react to key phases in the chronicle of human radio emissions. These extraterrestrial arrivals did more than simply confirm receipt of our signals. They showcased an intricate grasp of our tech evolution spanning many years. In Chile, the Atacama Large Millimeter Array kicked off a unified initiative to follow the crafts using precision down to the meter. VLBI, Very Long Baseline Interferometry, merged inputs from global radio dishes, forming an imaginary receiver spanning the planet's diameter. Such pinpoint location data proved remarkable, enabling skywatchers to spot minor path tweaks and orientation shifts invisible to standalone facilities. Findings from VLBI verified that multiple crafts executed delicate flight path alterations, slight shifts in speed and heading unaccounted for by mere gravity pulls or light pressure effects. These maneuvers looked intentional, refining the craft's routes to enhance Earth-based observation angles or sustain signal connection strength. Facilities for high-energy celestial studies entered the broad surveillance push. IceCube in Antarctica, built to catch neutrinos from universe-scale occurrences, scanned for unusual particle bursts, possibly linked to cutting-edge drive mechanisms. Ground-based showers of atmospheric particles hunted links between the craft's spots and bursts of energetic rays from space. Outcomes from these high-energy scans sparked heated disputes and doubts. Certain scientists reported spotting weak yet reliable ties between the arrival's locations and neutrino or ray incidents. Rivals saw nothing of the sort, blaming such reports on random data noise or flaws in processing methods. This clash highlighted broader doubts regarding the propulsion methods these outsiders employed. Standard fuel burns or atomic drives would emit nothing traceable across star-spanning voids. Yet wilder options like matter-antimatter reactors, fusion scoop drives, or physics beyond our ken could generate energetic bits catchable by our ground setups. Public-driven research surged forward at a scale and pace never seen. Zooniverse rolled out interstellar visitors, inviting helpers everywhere to sort brightness profiles and frequency plots. In mere weeks, vast crowds numbering in the hundreds of thousands added to the data crunching. Their shared work equaled lifetimes of effort beyond what expert stargazers could handle solo. Oddities noted by the crowd frequently triggered top-shelf telescope time at key sites. Hobby sky enthusiasts uncovered fine-grained timing quirks overlooked by pro-machine setups. Teens in secondary schools spotted rhythms in wave outputs, hinting at coding layers far beyond basic steady hums. This joint push marked the grandest unified science drive against one event ever recorded. Online networks turned into hubs for sighting records and processing kits. GitHub held freely shared code for wave handling and path math. All of Earth's people joined in our species' debut organized probe of outsiders from distant suns. Those managing orbital assets grappled with urgent hands-on issues. The craft's routes swept across busy zones near the sun. Alerts on potential overlaps reached those running satellites, cautioning against near misses. Intrusions neared the stationary ring around Earth and vital orbital hardware. Although these newcomers presented no immediate danger of impact, their erratic flight adjustments introduced fresh tiers of mission hazards. Underwriters started overhauling their frameworks for orbital junk impacts and signal disruptions. Suppose these arrivals proved less foreseeable than assumed. Imagine if their shifts turned bolder than what's been seen so far. The prospect of capabilities surpassing mortal comprehension added unforeseen elements to risk assessments once centered on environmental perils and operator mistakes. Public sentiment oscillated from awe to unease as additional arrivals dotted the skies during the warmer months in autumn of 2025. Stargazing clubs noted unprecedented turnouts at evening viewings and public telescope sessions. Yet those same assemblies, peering at the arrivals via lenses, mirrored profound doubts regarding humankind's role in a cosmos abruptly brimming with company. Online platforms hummed with hypotheses, from methodical scholarly guesses to doomsday visions. Trading floors exhibited odd swings in aviation and security sector shares, with speculators striving to assess the fallout from advances potentially eons superior to ours. Certain observers were convinced that a transformative revelation loomed for our species. Venture firms in orbital excursions saw a boom in reservations for brief hops beyond the atmosphere, seemingly under the notion that proximity to the void might offer an edge once the arrivals revealed their aims. Ad hoc shrines emerged at signal tracking facilities, drawing crowds to linger by the vast antennas, monitoring the entities live and absorb audio captures of their signals. The element that disturbed most involved the entity's evident synergy. With further arrivals materializing over the summer and fall of 2025, their signal outputs displayed timing links exceeding mere channel alignment. Short bursts of aligned signals flashed from various units at once, enduring mere instants yet unmistakably orchestrated over immense spatial gaps. The guiding mind behind this armada sustained ongoing links among its parts. These entities went beyond signaling our planet alone. They conversed among themselves, synchronizing maneuvers instantly across enormous separations. The ramifications for their signaling systems and structural complexity proved breathtaking. Come September, the registry listed 15 verified extrasolar bodies, alongside scores of prospects pending validation as trajectories clarified. The heavens teemed with constructed interlopers, everyone announcing itself via bands long deemed ideal for cosmic dialogue by our standards. The trend grew impossible to dismiss. Far from aimless stellar drifters or remnants of remote cosmic upheavals, these formed a deliberate expedition, carried out with exactness and unity, hinting at intellect and prowess, vastly exceeding ours. Doubt vanished about an attempt to reach out to our world. Now the puzzle centered on their intended words and our readiness to heed a dispatch that could redefine notions of cognition, innovation, and our cosmic standing. Part 4. A pattern in the noise. Did they catch our signals on purpose? The equations left no escape, weaving a tale that left skywatchers profoundly uneasy. Should these arrivals hail from stellar neighborhoods roughly 50 light-years distant, they must have picked up our broadcast generations back to sync their 2025 debut. Such logic pierced the enigma's core. How might they have first become aware of our presence? At MIT's Haystack Radio Observatory, Dr. James Chen undertook the challenge of piecing together the gradual outward spread of our radio emissions year after year. This examination demanded meticulous attention to factors like broadcast strength, directional antenna designs, and the inverse square principle, dictating how signals weaken as they travel through the void. Our various emissions weren't uniformly noticeable from vast cosmic reaches. Regular TV programming kicked off seriously around 1940, though initial setups lacked intensity and precise aiming. Those stray waves escaping into the cosmos remained faint, posing a challenge for pickup much farther than a handful of light years out. During the Cold War era, potent military radar arrays multiplied, generating robust pulses capable of traveling interstellar gulfs for possible interception. Yet their slim, scanning rays raked the heavens in rhythms that could obscure their engineered nature. Come 1962, humanity's strongest outflows radar setups aimed at charting Venus and monitoring asteroids hurled megawatts of radio waves at targeted sky zones. Such apparatus functioned on wavelengths picked for prime planetary scrutiny, yet they forged the most luminous radio footprints ever left by our world. Finished in 1963, the Arecibo Observatory emerged as our species' loudest call into the universe. With its 305-meter reflector, it could hurl 1,000,000 watts of radio power in a narrow, concentrated stream. Employed for radar scans of planets, Arecibo produced radio marks vivid enough for like-minded installations light years away to catch. The chronology proved stark and exact. Civilizations no more than 50 light-years off would have picked up our initial TV waves by 1972 and 1982, as those signals finished their light-speed trek through the stars. Our fiercest radar blasts would have arrived at close stellar neighborhoods by 1992 and 2002, offering unmistakable signs of advanced life here on Earth. Yet these arrivals didn't coincide with mere chance. Backtracking their incoming paths via intricate orbital dynamics math through the galaxy revealed ties to particular stellar setups ideally placed to monitor our planet amid our noisiest emission phases. Linking these paths demanded utmost caution to sidestep the data pitfalls that had doomed prior hunts for cosmic trends. At the Harvard-Smithsonian Center for Astrophysics, Dr. Sarah Martinez guided a group that matched the arrival's starting directions against our world's emission histories over many years, employing Monte Carlo methods to gauge chances of false links. HD 164595, a star much like our Sun located 94 light-years distant, lay right along the route of our mightiest Arecibo blasts from 1972 and 1982. The alignment fit flawlessly as Arecibo trained on Venus for radar charting. Its ray grazed the spot where HD 164595 hung in the firmament. Listeners there would have grasped our planet's radar pulses with such sharpness that their crafted source shone beyond doubt. Wolf 359, a mere 7. 9 light-years off would have tuned into our TV waves with exceptional sharpness thanks to its spot compared to our world's spin axis. This red dwarf perches almost at right angles to our globe's waistline, allowing a vantage that boosted intake of our top commercial airings. Tau Ceti, often eyed in SETI quests for its nearness and solar-like traits, synced up neatly with key radar drives from 1992 and the dawn of 2002. That stellar cluster would have gathered solid proof of tech on Earth, right as our farthest probe started unveiling the solar system's secrets. Statistical correlations emerged at a 4 sigma significance level from the data examination. The likelihood that these alignments arose by mere chance hovered around 1 in 15,000. Within particle physics, findings of this caliber would signal robust indications of novel discoveries, a standard that carried over compellingly into astronomical inquiries. Even doubters among experts had to acknowledge the weight of such results for deeper scrutiny. Skeptics, however, pointed out the risks inherent in this kind of scrutiny, particularly the phenomenon statisticians term the "look elsewhere" effect. This refers to the inclination to uncover spurious links when sifting through vast datasets with ample leeway in analytical approaches. Given the multitude of proximate stellar neighborhoods and the long chronicle of Earth signal emissions spanning years, incidental matches were bound to surface, regardless of any underlying genuine ties. Leading the charge against these interpretations was Dr. Robert Hayes from the University of Arizona. His group ran comparative studies on shuffled datasets and varied statistical techniques. Their results demonstrated how seemingly meaningful links might stem from random juxtapositions, intertwined with detection prejudices and the innate human drive to discern order in chaos. In a prominent article in the Astrophysical Journal, Hayes contended that our pattern seeking stems from desire rather than reality. Supply people with ample records of their signals alongside extraterrestrial arrivals, and they will weave links across disparate elements. Cosmic reality bears no duty to heed our electromagnetic dispatches. Yet, the rhythmic sequencing in the extraterrestrials' approach chronology offered far more persuasive proof, transcending mere spatial symmetries. These entities did not manifest at haphazard cadences governed solely by celestial orbits. Instead, their intervals resonated with pivotal chapters in humankind's signaling legacy, exhibiting an exactness hard to wave off as fluke. Dr. Lisa Johansson of the SETI Institute introduced the echo hypothesis, framing every arrival as a deliberate reply to particular terrestrial emissions. Should these interlopers truly represent retorts to our outreach, their timelines ought to reflect our emission landmarks, offset by propagation delays across interstellar voids and the duration of their voyages. Johansson devised a quantitative framework positing travel speeds at 10 to 20 of light velocity, impressive by earthly measures, yet feasible for societies wielding sophisticated drive systems. Her framework forecasted entry moments drawing from the potency and chronology of our planet's most potent radio outflows, adjusted for the odds that assorted stellar locales intercepted them. The concordance between these forecasts and actual sightings proved strikingly close. 3 Atlas aligned with the epoch responding to the zenith of terrestrial TV dissemination in the 902nd year. 4 I synced with echoes from nascent defense radar setups. 5 I tied to the phase of widespread orbital relay networks. These alignments implied not mere sentience, but a watchful awareness tracking our tech evolution over spans of many years. The sharpest validation arose from dissecting the informational content in the intruder's radio outflows via theory of communication. Multiple craft displayed emission motifs seemingly alluding to the 4974 Arecibo message. This renowned 3-minute dispatch aimed at the dense stellar aggregation M13. The Arecibo dispatch incorporated binary encodings of numerals from 1 to 10, succeeded by atomic masses of hydrogen, carbon, nitrogen, oxygen, and phosphorus core building blocks of DNA. It featured a depiction of the helical DNA form, a basic sketch of humankind's silhouette, and an illustration of our star system highlighting Earth as the third world orbiting the Sun. Certain intruder broadcasts harbored analogous numeric escalations, yet with nuanced alterations hinting at purposeful tweaks over rote copying or static interference. Their binary chains remained identifiable, though they ventured past the confines of the prime Arecibo blueprint. Among the intriguing elements were advanced ideas in mathematics that people on Earth had uncovered yet never transmitted outward. Sequences of prime numbers stood out vividly, offering what might be the most compelling sign of purposeful signaling. The Arecibo transmission had employed primes as a timeless idea in math, one that any advanced society could grasp, no matter their method of numbering or symbols for equations. A few of the incoming signals sent back their versions of prime lists, like 2, 3, 5, 7, 11, 13, 17, 19, 23, yet they strayed from the usual lineup in manners that felt intentional, not haphazard. It resembled a reply along the lines of, "Your signal reached us, and we decoded its numeric tongue. Here are our twists and expansions to reveal the depth of our own numeric prowess." Those shifts lacked randomness. Instead, they aligned with intricate principles from higher math, such as twin primes, Sophie-Germain primes, Mersenne primes. These signals revealed an expertise in numbers far past simple tallying, echoing ideas that Earth scholars had built through ages of study. Scrutinizing the numeric elements demanded utmost caution to sidestep the allure of spotting designs in cluttered information. The group led by Dr. Chen locked in their predictions ahead of examining the incoming signals, pledging to certain analytic checks and levels of importance. They ran Monte Carlo models to gauge the odds of spotting seeming numeric designs in mere chance noise. Despite such strict protections, the links held up under stats scrutiny. The chance that stray radio waves would hold identifiable numeric chains tied to Earth sends was under 1 in 10,000. These entities showed grasp of our math and built upon it in fashions that confirmed their smarts and tech prowess, though doubters in the field resisted these views fiercely. The clash unfolded with fervor in scholarly publications and online forums alike, highlighting deep rifts on judging bold assertions from sparse info. Hayes, along with his team, claimed the seeming numeric elements mirrored our mindset more than extraterrestrial exchange. Seeing designs lies at the heart of how we think. In their words, our ancestry shaped us to detect useful cues amid chaos. Viewing space events via that inherited filter makes us likely to spot minds where only chance stirs. The numeric debates grew sharper as each camp honed their approaches and premises. Backers of the smart entities idea highlighted the varied standalone proofs, shape matches, time rhythms, numeric material, and synced actions among various craft. Opponents stressed risks from testing many ideas at once and our knack for deeming big troves of data as meaningful. The tussle drew eyes from thinkers on science and stats pros. The National Academy of Sciences gathered an expert group to weigh the proofs and steer ongoing work. Their initial summary used measured language, yet admitted these entities posed events worth deep probe with top-tier tools. Online platforms boosted the stir, with tags like number pattern or pareidolia surging globally. Evening comedy shows poked fun at our self-centered ways, supposing we take every space quirk as a nod to ourselves. Yet experts in science treated the probe with gravity, aware that even slim odds of deliberate reach held vast stakes for our kind's path ahead. The Working Agreement. After extensive review spanning months amid intense discussions, the final statement emerged with precise phrasing. Links tying Earth's broadcast records to the intruder's traits proved robust in statistical terms, defying dismissal as mere chance or viewing errors. If this signaled deliberate outreach stayed unresolved, yet the consistencies warranted organized efforts to reply. That notion of organized efforts to reply held deep implications. It hinted at humans possibly sending signals in return to gauge if the intruders would acknowledge our messages promptly. The concept stirred equal parts excitement and dread. Humanity's debut, deliberate exchange with minds from distant stars. Following years of mere reception, we pondered joining what could rank as the cosmos's longest-running and vital dialogue. The intruders seemed to offer their initial message, revealing grasp of our numbers, our past, and our spot amid the stars. The core issue lingered, our preparedness to answer and the insights from entities skilled in bridging vast cosmic gaps. Section 5, Dissecting a Mystery. The physical form of 3 Atlas? Come October 2025, data gathered from scores of global telescopes yielded the sharpest ever sketch of a star-traversing body. The resulting image resisted straightforward labels. 3 Atlas spanned about 200 meters along its greatest extent, with a breadth near 20 meters and a slimness radar scans indicated below 2 meters. Its proportions surpassed 10:1, positioning it among the slimmest shapes spotted in our solar realm. The form evoked a slender sheet or layered sheets, perhaps jointed, capable of shifting form. Subtle yet clear extra-gravity pushes marked the body. Nearing its solar closest point, slight strays from pure orbit paths built up to noticeable path shifts. These pushes stayed uniform, directed toward the sun or away, devoid of chaos. They aligned with forecasts for light push on a mirror-like face, though the body's noted reflectivity fell short to explain them. Light scatter studies uncovered outer makeup alien to known rock files. The readings displayed soak lines matching rare carbon forms, substances likely crafted over wild origins. Suggestions of boron nitride layers appeared, alongside metal flecks patterned to imply purposeful infusion for targeted wave traits. Heat patterns stood out as the naughtiest feature. While 3I Atlas traversed varying sun distance zones, its warmth strayed from the basic distance-squared drop-off ruling typical local bodies. Rather, it displayed steady heat levels, zones of near-fixed warmth amid fluxing sun exposure. This pointed to deliberate heat control, maybe via tiny adjustable slats or smart material skins tunable for emission on the spot. Spin control matched this precision. In contrast to wild rocks flipping wildly from impacts and pulls, 3 Atlas held a fixed turn pole matched to key sky markers. Even more captivating, its turn cycle displayed faint shifts tied to sunlight angles, as though the body tweaked its pose to best harvest sun power or handle heat. Broadcast waves offered the strongest case for crafted design. The main tone at 1424 MHz came with overtones spaced at exact numeric gaps. At first, the broadcast lacked variation, merely a pristine narrowband signal, altered by Doppler effects from the entity's movement, emerged clearly. Yet, upon 33's nearing of perihelion during November, distinct modulations surfaced. The rhythm proved impossible to mistake. Pulses clustered to match primes like 2, 3, 5, 7, 11, 13, 17, 19. This progression extended across the initial dozens of such numbers before cycling back. SETI experts had anticipated precisely this type of transmission as initial contact from extraterrestrial minds complex in its numerical elegance, yet straightforward enough to flag as non-natural. At Harvard, Dr. Abraham Lowe outlined key markers for spotting engineered visitors from other stars, such as odd luminosity from afar, signs of unnatural propulsion, and radiated energy signatures. 3 Atlas seemed to meet everyone. Assuming typical albedo, Lowe calculated that the detected glow at initial range implied the thing produced roughly 10 gigawatts internally, powering something on the scale of a modest urban area. Skepticism persisted among leading stargazers. Shots from the Hubble Space Telescope revealed a hazy envelope encircling 3 Atlas, aligning with vaporized ice and particles as proximity to the sun warmed it. That day's spotlight image in astronomy highlighted these visuals, with notes underscoring routine comet-like activity. Telescopes on Earth picked up traces of H2O gas and CO right beside it, bolstering ideas of ordinary origins. Still, standard comet mechanics fell short of explaining everything spotted. The expelled material seemed insufficient to drive the odd, gravity-defying pushes. Irregularities in the envelope's form hinted at deliberate releases over mere evaporation. Strangest of all, the radio bursts persisted at aphelion. the spot farthest from the sun, defying expectations for natural ionized gas activity to fade. Rival theories sharpened the discussion. Pro-natural views drew on rare yet credible ideas. Imagine a chunk broken from a shattered comet, bearing quirky makeup and shape, maybe embedded with metal bits sparking radio waves via charged particle clashes. Steady spins and heat responses could stem from hidden compartments, voids in compartments, fostering heat retention and spin steadiness. Ideas leaning artificial ventured bolder ground, yet match the data uncannily well. Picture a self-guided scout or signal bearer harnessing sunlight for energy and orientation. Its slender build evoked fold-out designs, like a broadcaster setup optimized for capturing rays and beaming signals across vast areas. That prime lineup bespoke not mere smarts, but awareness of Earth's number lore. A hybrid notion arose, bridging the organic and the made. From the University of Barcelona, Dr. Elena Rodriguez suggested 3 Atlas could be biotech wreckage, leftovers from lifeforms mastering nanoscale fabrication. Perhaps it held vitality, relying on organic mechanisms to sustain form and actions over cosmic voids. As 3IE Atlas neared its Earth skim in November's end, hazard evaluations took center stage. It would zip by at 0. 3 astronomical units, roughly 45 million kilometer near for scrutiny, yet distant enough to spare orbital nudges to our world. Graver loomed the chance of fragment breakup. Should it prove crafted and worn from eons in the void, bits could peel off its solar closest approach. The Global Planetary Safeguard Hub sent measured alerts to orbital outfits everywhere. Though 3 Atlas offered no crash risk, its actions stayed unpredictable. Evidence of deliberate speed changes demonstrated that the entity possessed the ability to navigate. The key uncertainty involved determining if these movements stemmed from reflexive reactions to sunlight exposure or indicated deliberate control from an intelligent entity. Additional satellites introduced further intricacy. Multiple minor components, labeled 3 Atlas A through 3I Atlas F, moved alongside the main body in synchronized patterns. These segments exhibited comparable signal outputs and joint movements, implying they could serve as alignment reflectors or transmission relays within a spread-out network for messaging. Power demands revealed a stark reality. Just the signal broadcasts demanded thousands of watts, a hefty amount for something with constrained sunlight-gathering surfaces. Should these outputs truly constitute purposeful signals instead of mere byproducts, they signaled a major investment of effort. An entity or force was expending vast amounts of power to make certain their voice reached us, right as 3 Atlas hit its nearest point to the sun on November 28, 2025. Stargazers worldwide paused in anticipation. This marked the instant of minimal distance, peak temperatures, and, should the entity prove constructed, likely peak operations. All prominent ground-based scopes across the planet focused intently, eager to uncover what this profound cosmic enigma might disclose regarding its nature. Part 6. Talking Back, Protocols, Politics, and the First Reply. Once Skywatchers verified that 3I Atlas was sending sequences of prime numbers, humankind grappled with an unprecedented dilemma. What steps does one take to reply to an extraterrestrial dispatch? Over many years, the International Academy of Astronautics had crafted after-discovery procedures for SETI detections. These recommendations formed a thorough yet non-binding outline for checking, examining, and ultimately replying, presupposing that nations would align via established agreements. Yet no pact foresaw arrivals capable of steering and engaging in direct dialogue during a solar system transit. The UN Committee on the Peaceful Uses of Outer Space called urgent meetings in Vienna. Known as COPUOS, it had managed issues ranging from orbital junk to private rocket flights, though never cross-star negotiations. The Committee on Space Research, COSPAR, contributed thoughts on safeguards against biological spread, first intended to shield Mars and Europa from earthly microbes. Could identical rules extend to engineered arrivals from distant suns? The International Telecommunication Union confronted pressing issues. Spectrum bands counted as sovereign assets, meticulously divided to avoid clashes among earthbound operations. Yet, How does one handle when an off-world mind begins emitting on channels set aside for radio astronomy? The ITU's duty in safeguarding SETI ranges abruptly turned vital for avoiding disruptions in our initial exchange with the universe. In private discussions, the discourse grew far sharper. Country-run space programs recognized that the initial reply could establish a kind of priority in cosmic dialogues. NASA's Deep Space Network held the means to contact 3i Atlas using current setups. The European Space AI's ESTRAC network offered equivalent reach. China's advancing deep space messaging setup was swiftly matching levels of Western counterparts. Still, the strongest broadcasters resided with defense groups and scholarly labs. The Arecibo Observatory in Puerto Rico, even after its latest framework failure, once stood as the planet's mightiest radio dish. Its successor, the planned next-generation Arecibo telescope, lingered far off in development. Leadership had shifted elsewhere. The 500-meter aperture spherical telescope FAST in China enhanced setups at Goldstone and Canra, and university-operated arrays like the Very Large Array in New Mexico. Dr. Jill, an improbable leader, arose in Tarta, once at the helm of the SETI Institute. Her long years devoted to detecting signals from beyond our world lent her unparalleled expertise in outlining guidelines and methods. In urgent gatherings alongside global experts, she remarked that humanity had long anticipated such an event. The core issue revolved around uniting as a single race or clashing as rival countries. Considerable yet surmountable hurdles arose on the engineering front. Addressing 3i Atlas demanded adjustments for its swift trajectory and varying proximity. Real-time Doppler shifts necessitated exact monitoring and immediate tuning of frequencies. Signals dispatched had to possess sufficient strength to bridge vast cosmic gaps, yet stay focused in bandwidth to unmistakably signal intelligent origin. Drawing from SETI heritage and principles of data conveyance, the exchange framework took shape. Start via numerals that shared tongue across realms. Mirror back the progression of primes to a firm grasp. Progress to intricate ideas next, like molecular builds, unchanging laws of nature, or maybe a basic chart of stars marking our spot amid the Milky Way. Fierce arguments erupted over what details to include. Defense experts cautioned sharing details on planetary systems or protective strengths. Researchers countered that interstellar voyagers would inherently know our tech bounds. A straightforward resolution won out with refined grace. Echo the very data we'd intentionally sent before. Update the numeric and natural principles from the 1974 Arecibo dispatch with today's insights. The encoding method required basic decipherability for any mind, while complex enough to hold substance. Experts chose pulse placement coding, bolstered by robust redundancy checks, deliberately sluggish and wasteful, yet nearly impervious to distortion. Distinct Barker patterns would deliver clear openings, numeric strings screaming non-natural design. The pressing limit was duration. Throughput. Atlas lingered in prime contact zone for mere weeks. Its blistering speed ensured planetary spin yielded short slots for dialogue as varied dish arrays aligned. Adaptive planning tools, first crafted for far-flung probe follows, got redirected to stretch interactions with our debut cosmic pen pal. Verification chains guaranteed all sends logged and authenticated. Digital seals blocked future doubts of tampering or invention. Diverse sites kept separate logs, forging an enduring vault of our initial deliberate outreach to alien minds. On December 3, 2025, the go-ahead for sending arrived. 3 Atlas neared its peak alignment from our vantage, with signal hunters verifying the entity's prime chain growing ever more elaborate. This intruder displayed numeric prowess, stretching well past basic tallying. From the upgraded Arecibo site, now jointly managed worldwide, Dr. Martinez initiated the beam. It opened mirroring the prime string 3 Atlas kept emitting, proving reception and insight. Next followed initial periodic entries in digit pairs. A basic hydrogen sketch appeared after. Precisely the idea setting our talk's wavelength. Reply arrived after 18 minutes. The round-trip photon lagged to 3i Atlas. The incoming wave shifted. Constant prime flow morphed into richer designs. Pulse clusters matching element orders. Hydrogen, helium, lithium, beryllium. Yet afterward, the pattern veered away from the familiar layout of our planet's elemental chart, incorporating signal clusters unlike anything in recorded science. It felt like the intruder was imparting lessons in chemistry beyond our current grasp. Even more astonishing proved the transformation undergone by the entity. Earthbound observatories picked up a faint glow, a quick blink resembling a camera's snap that matched precisely the duration of our broadcast. Photometric examination indicated that a section of 3I Atlas had altered its form, possibly unfolding shiny surfaces or shifting its angle to produce an optical reply to the wireless dialogue. The consequences proved mind-boggling. This went far beyond mere echo of some cosmic event. This represented deliberate, immediate interaction with a mind capable of syncing electromagnetic waves and light signals over vast planetary gaps. Reports of the fruitful interaction spread rapidly in mere hours, regardless of strict secrecy measures. Hobbyists scanning radio bands globally had tracked the channels, and the unique signal rhythms proved impossible to conceal. Online platforms buzzed with thrill and guesses. Officials hurried to release declarations, stressing restraint and global teamwork, yet the core reality stood firm. Our species had effectively started a dialogue with beings from a distant stellar realm. 2 days afterward arrived the follow-up interaction. On this occasion, 3I Atlas started the outreach, sending a richer numerical progression. The designs seemed to outline celestial paths, the paths traced by bodies near massive attractors. Once our experts unraveled the complete code, they grasped that the outsider was detailing not only broad principles of orbits, but the exact road it pursued amid our star's domain. It revealed awareness of its location and destination. Far more crucially, it showed that its arrival in our cosmic neighborhood stemmed from intent. The path had been plotted, arranged, carried out over star-spanning voids with accuracy, hinting at capabilities we could scarcely fathom. The outsider did more than respond to our signal. It clarified the means by which it detected us, journeyed to reach us, and aligned for the clearest exchange. The ensuing exchange would upend all our notions of humanity's role amid the cosmos and our destiny beyond our world. Yet initially, we needed to comprehend the galactic insights 3I Atlas sought to impart about the starry expanse we believed familiar. Part 7. Earth Reacts, Psychology, Faith, Markets. As soon as word spread of the two-sided link with 3I Atlas, the shared human mindset altered profoundly in manners demanding years of study from social experts. Support lines for emotional well-being saw a 340 surge in inquiries over the initial 7 days post-revelation. The discussions mirrored expected themes: dread over our species' cosmic standing, intense eagerness for what lay ahead, and an odd sense of stellar isolation. The dawning that solitude had never truly defined us, though we'd clung to that illusion for ages. At Stanford's Mind Science Center, Dr. Susan Chen named the phenomenon contact syndrome for the array of responses she noted among clients. Individuals described intense visions of interstellar voyages, compulsive stargazing habits, and an abrupt view of daily worries as insignificant. People seem to be stealing their thoughts for an era beyond their current vision, she observed in early findings. Faith-based reactions differed sharply by creed and tradition. Within 2 days, the Holy See released a measured pronouncement affirming that extraterrestrial minds aligned with church doctrine. The cosmos stretches wide, brimming with marvels. Pope Francis stated, "If God has chosen to populate it, encountering diverse minds from distant stars merely amplifies our appreciation for the boundless ingenuity of the divine." Responses from evangelical Protestant circles proved far more varied. Certain figures welcomed the arrivals as proof of divine reach across the cosmos. In contrast, some expressed concerns over doctrinal consequences. Could entities from remote planets hold spiritual essences? Might the redemption through Christ reach past our globe? Urgent assemblies of theologians gathered in religious institutions globally, wrestling with dilemmas once confined to abstract debate. Scholars of Islam discovered firmer footing in scriptural mentions of divine works extending over various realms. Buddhist authorities described the encounter as validation that awareness forms an essential trait of existence. Hindu perspectives, long at ease with vast celestial dimensions and layered planes of being, integrated the fresh circumstances with the least disruption. Meanwhile, economic sectors underwent what analysts eventually termed the encounter adjustment. Shares in aviation and security firms climbed at first, fueled by guesses on innovative devices and state deals. Yet these rises proved unsteady, plummeting abruptly once initial reviews indicated the newcomers harbored no aggressive aims. Firms handling orbital broadcasts faced steep alterations in coverage costs as risks of disruption, deliberate or not, from superior extraterrestrial systems introduced fresh risk classifications. Costs for uncommon soil minerals jumped on bets that off-world devices could demand unusual substances. The metal vital for power cells and devices in consumer goods saw its value double over 7 days. Precious yellow metal, long a refuge in times of doubt, displayed unexpected steadiness. Evidently, market participants figured that entities mastering voyages between stars would value gleaming ores far less than earlier human eras had imagined. Digital asset exchanges provided an intriguing glimpse into shared mental states. The leading virtual tender's worth skyrocketed amid ideas that non-centralized electronic monies could appeal to cosmic merchants. Fresh encounter-themed tokens emerged each day, many sophisticated frauds, though others embodied sincere efforts to devise exchange methods, bridging interspecies divides. Cyber conflict exploded on networking sites right away. Automated swarms, often seemingly backed by nations, inundated Twitter, Facebook, and TikTok with rival stories. Certain posts alleged the whole arrival incident amounted to a grand deception by global powers to enable tighter monitoring. Different voices asserted the arrival signaled a conquering army and called for swift armed readiness. Site overseers confronted the novel task of validating assertions regarding off-world minds. Twitter's rules group labored intensely to craft rules for otherworldly material, even as they battled false info on the arrival's goals and strengths. Authenticity markers showed up on sanctioned stellar watch posts, establishing a fresh tier of reliable outlets for stellar updates. Learning networks hurried to address abrupt learner curiosity in celestial studies, signal engineering, and life beyond Earth. Higher education centers noted record signups for natural science and number theory classes. Local learning hubs started rapid programs in broadcast mechanics, instructing learners to assemble personal detectors for tracking cosmic transmissions. Youngsters' responses stood out vividly. Educators noted that pupils were weaving orbital motifs into drawings and imaginative tales with striking depth. Numerous kids appeared far less startled by the encounter than grown-ups, behaving as though they had long expected the cosmos to team with other thinkers and were simply biding time for elders to catch on. The creative sphere reacted with its typical fervor. Galleries arranged hasty displays of orbital-inspired pieces. Fresh musical pieces, artistic expressions proliferated nearly every day, frequently weaving in patterns based on prime numbers or the precise radio signals picked up from 3i Atlas. Creators in the visual realm built exhibits that drew on the hydrogen line's frequency, 1420 MHz, as a core framework, converting it into vibrant hues, designs, and three-dimensional shapes. Customs among people arose naturally. Gatherings for listening sessions gained widespread appeal as communities clustered near receivers set to channels where the arrivals could potentially transmit. Clubs dedicated to stargazing saw a surge in recruits, all keen to spot the extraterrestrials via optical instruments. The online tag for outer space turned into a worldwide sensation, drawing countless individuals who shared notes aimed at cosmic recipients. Capturing the evening heavens through lenses boomed among hobbyists. Those new to photography among skywatchers quickly acquired long-range optics and stabilization gear, driven by the wish to record glimpses of the far-off travelers. The resulting snapshots offered little spectacle, mere faint gleams hard to tell from celestial bodies. Yet the simple ritual of snapping and distributing these images fulfilled an innate urge to record and connect over this landmark event. For the first time in generations, City Glow turned into a contentious civic matter. Local governments encountered demands to enact rules for darker nights, reducing excess illumination to enhance views of the cosmos. Retailers of tools noted a lack of crimson torches, favored for maintaining dark adapted sight in evening observation outings. The mental effects reached into surprising domains. Courtships often now invoked the vastness of the universe in commitments. Platforms for romance integrated opinions on alien encounters into their pairing systems. Adoptions of animals rose sharply, hinting at a quest for bonds amid ambiguity. Businesses in promotion shifted tactics swiftly. Ads for vehicles showed households heading to remote spots for clearer stellar sights. Makers of mobile devices highlighted their devices' prowess in dim conditions for celestial imaging. Brewers of Java promoted special mixes suited to extended vigils under the firmament. Yet the deepest transformation might have been more understated, a realignment in how time was perceived. Folks started viewing matters over extended eras, weighing choices against the sweep of universal timelines instead of short-term profits or voting periods. Talks on city development now pondered adaptations for a race aware of its place among others in the cosmos. Studies into the mind's response would persist for ages, though initial trends stood out. Our kind wasn't merely grappling with the reality of distant intellects. We were starting to see our place within a broader network of thoughts dispersed through the stars. The solitude that had shaped our awareness from those initial gazes skyward was at last, hesitantly, starting to fade. Part 8. Constructing an expedition in mere months rather than spanning years. Come January 2026, what once seemed unattainable now felt certain. Our species would dispatch a vessel to link up with 3I Atlas. The framework for the venture arose from urgent strategy meetings uniting top minds from NASA's engineering teams, ISA's planners for flights, and delegates from private firms that had subtly transformed entry into orbit. The task ahead had no equal, involving pursuit of an object hurtling at speeds across voids, with only weeks for liftoff instead of years. Conventional approaches to such endeavors expected timelines stretching 10 years or beyond. The Voyager craft needed 8 years from idea to ascent. The James Webb Space Telescope demanded 3 decades from first pitch to functionality, but 3 Atlas refused to pause for earthly red tape. By mid-2026, the newcomer would be speeding past solar bounds, out of range for any vessel we might feasibly build. The answer rested in utilizing components already built or quickly adaptable. The strategy underwent swift adjustments. SpaceX's Super Heavy booster, initially crafted for voyages to Mars, possessed the capacity to transport hefty cargoes along paths spanning the planets. Propulsion setups relying on solar electricity, validated through expeditions to asteroids, offered the exact steering essential for rendezvous. Assembling these elements into an operational venture within under 8 months posed the core difficulty. Dr. Robert Braun, once affiliated with NASA's Jet Propulsion Laboratory, directed the International Mission Design Team. His approach emphasized unyielding practicality, rely solely on validated tech, embrace elevated dangers beyond standard operations, and concentrate solely on goals attainable amid a short pass-by interaction. The core mission outline shone through its straightforward elegance. One sizable probe would blast off in June 2026 via a low-energy path to meet 3I Atlas come September. The close pass would span about 6 hours, over which the probe would release several compact devices crafted to near the intruder from varied directions, all while keeping secure separations. Directing, steering, and managing stood out as the prime engineering hurdles. 3 Atlas emerged as a slender, spinning objective with erratic propulsion options. Conventional sweeps past asteroids depended on exact path forecasting, yet this intruder had already shown it could execute minor path tweaks. The probe required self-governing steering mechanisms able to adapt to the objective's shifts instantly. Choices for instruments mirrored pressing research needs. Broad-spectrum radio detectors would scan all emissions from 3 Atlas, hunting for outreach efforts or data signals. Visual imagers fitted with diverse lenses would record the item's material makeup and outer traits. Laser-based comms gear would seek to forge wide-channel links, probing if the intruder might reply to light pulses alongside radio waves. In the most debated aspect, the venture incorporated tiny explorers built for ultra-near passes, possibly mere meters from 3I Atlas's exterior. These touch devices carried collection tools that might gather samples should chances emerge, though their main aim involved thorough scrutiny and direct signal broadcasting up close. The James Webb Space Telescope's involvement turned pivotal for venture triumph. JWST's capacity to track shifting aims, restricted to items advancing below 75 milliseconds per second, held promise for viewing 3I Atlas along certain segments of its route. Of greater note, JWST's heat-sensing prowess could spot warmth traces unveiling hidden makeup or power origins. Global arrays of very long baseline interferometry synchronized to yield micro-arc-second location fixes for 3I Atlas. Such accuracy, derived from merging feeds of radio dishes spaced across vast landmasses, would allow path forecasts precise sufficient for probe-meeting computations. The Rubin Observatory's Legacy Survey of Space and Time, set to launch complete activities in 2025, brought yet another edge. LSST's broad-scope scans could spot coming star-crossing arrivals sooner, granting extended prep periods for venture setup. Insights gained from the 3 Atlas pass-by would shape quick-action guidelines for later arrivals. Debates over gathering samples stirred intense arguments among researchers. The Committee on Space Research, COSPAR, had set safeguards for mission varieties, yet nothing covered gathering from possible crafted items beyond our stars. Was 3 Atlas merely a cosmic event treatable as any space rock? Or did it embody assets of some foreign mind deserving, should the enigmatic visitor be handled through diplomatic channels instead of purely scientific ones? The agreement struck a careful balance. Efforts to collect samples would proceed solely in cases where 3I Atlas seemed to be releasing substances on its own or when the entity signaled some kind of evident permission via its signaling behaviors. Physical interaction with the core form would be steered clear of, except in dire circumstances essential to achieving the objectives. Remarkably, global collaboration unfolded without major hitches. The mission's vast scope and urgent schedule demanded assets beyond any one country's swift reach. NASA offered expertise in launches and operational management. ESA delivered reliable engines and guidance programs. Private firms furnished gear for signaling and processing power. This setup established a model for subsequent joint ventures aimed at atypical destinations. Formulating backup strategies demanded immense labor. Suppose 32 Atlas altered its path without warning? Suppose it activated protective measures or scattered obstacles? Suppose outreach efforts provoked aggressive reactions? Every possibility needed preset countermeasures operable on their own, given the 8-minute lag in signals to ground stations that ruled out instant oversight. The sequence of the rendezvous was orchestrated with the exactness of a military drill. First approach would happen at 10,000 km away, safely outside potential wreckage zones, yet near sufficient for thorough scrutiny. The primary vessel would hold that separation while releasing tiny scouts for nearer examination. Outreach via signals would kick off right away, spanning all possible bands and encoding methods. With the June 2026 liftoff drawing near, worldwide focus sharpened on the endeavor. In contrast to earlier planetary ventures that stirred only mild curiosity, the 3 Atlas rendezvous ignited universal fascination. Aboard went greetings from global figures, drawings by kids chosen via worldwide contests, and emblems of earthly culture. The meeting proper would prove short yet historic. Over 6 hours, people would gain their nearest glimpse of arrivals from a distant solar realm. Insights from the effort could resolve core inquiries into the essence of wanderers between stars and the prospect of alien minds. Even more vital, the venture would showcase humanity's skill at seizing stellar chances with speed. Yet, while the craft hurtled to its date with 3 Atlas, experts braced for revelations that could upend all notions of cognition, machinery, and humanity's cosmic standing. Part 9, Proof or Pareidolia, the Scientific Knife, Edge, grasping when truly remarkable findings emerge, stands as the toughest aspect of bold inquiry. Dr. Elena Martinez grasped this truth while gazing at the influx of information from humankind's inaugural star-crossing meetup. The session with 3i Atlas spanned 6 hours and 17 minutes, yielding terabytes of records needing months for complete review. Yet early findings sparked far more puzzles than solutions. Thus, researchers teetered on the sharp divide separating breakthrough from illusion. Bold assertions demand robust proof, a tenet steering SETI pursuits for generations. Yet how does one gauge boldness amid events utterly novel to observation? The hurdle extended past mere dissection of records from 3 Atlas. It involved crafting fresh paradigms to assess assertions of alien awareness. Over time, empirical approaches had refined methods to sidestep misleading detections. Locked-in studies compelled investigators to lock onto precise predictions prior to data review, blocking subtle biases that might recast random patterns as meaningful ones. Researchers tested detection algorithms by slipping bogus signals into datasets unbeknownst to the scientists, checking if the systems could separate genuine events from fabricated ones. Separate processing chains, crafted by various groups with distinct tools, offered mutual verification for key outcomes. When 5 separate crews, handling identical information through varied approaches, arrived at matching verdicts, those results earned solid trust. Divergent views, however, signaled the call for deeper investigation. Rival theories about 3 Atlas divided into 3 main types, each boasting unique forecasting structures and empirical checks. The idea of an engineered light cell put forward that 3 Atlas constituted a man-made creation, likely self-operating, built for cosmic messaging or scouting. Such a theory accounted for the item's radical shape, regulated spin, heat regulation, and radio bursts. It foresaw that in-depth scrutiny would uncover substances or builds clashing with ordinary genesis methods. The notion of an unusual natural shard posited 3 Atlas as an unfamiliar breed of space wanderer, maybe rubble from a star smash-up or a comet's breakup holding odd stuff. This view might clarify the item's weird traits, sans calling on man-made roots. It anticipated that spectrum studies would ultimately disclose innate, albeit uncommon, creation paths. The standard comet theory insisted 3 Atlas mirrored 2 Boris at its core, with seeming oddities stemming from viewing glitches, picking flaws, or misread innate workings. This theory expected finer probes to expose typical comet actions hidden by the item's quirky tilt and makeup. The building proof weighed each theory in varied ways. Radio bursts leaned heavily toward crafted beginnings. Everyday forces seldom yield tight band transmissions bearing numeric rhythm schemes. The managed spin and heat control likewise aligned better with built devices over raw bodies. Yet, spectrum readings stayed unclear. Though 3 Atlas displayed peculiar outer reactions, judging if those elements sprang from nature or craft demanded grasping birthways possibly unique across the stars. Rare didn't automatically spell built. The flyby probe delivered vital fresh insights. Near-pass photos showed outer features looking arranged, not haphazard, hinting at intent over innate erosion or impact scars. Still, pareidolia, the habit of spotting designs in nothingness, had tricked people across ages. Mars's channels once struck 19th-century stargazers as plainly built. Beam signaling trials amid the flyby yielded the most intriguing findings. As the probe sent patterned light flashes at 3i Atlas, the item's outer gleam shifted in ways seeming to match the send pattern. Yet light tricks in void settings can prove tricky, and proving those shifts as replies instead of flukes needed stats work still in progress. The backdrop of Oumuamua offered lessons in wisdom and wariness. That initial space intruder displayed push-free thrusts that first baffled experts. Thinkers floated wild ideas, bits of off-world tech, icy hydrogen bergs, or even hints that Oumuamua could be a sail from distant folk. Yet thorough review by Dr. Marco Michicelli and his team, issued in Nature back in 2018, proved those thrusts stemmed from standard comet venting. The peculiar shape and absence of any evident coma at first concealed Oumuamua's true cometary character, though in-depth simulations ultimately revealed how ordinary cosmic mechanisms could fully justify every trait detected. This insight proved humbling. Far-fetched ideas must serve as a final option, never the initial one. Even improbable everyday accounts warrant careful scrutiny ahead of any appeal to alien minds. In contrast, Boris offered a valuable counterexample. It stood as a straightforward interstellar comet, acting precisely in line with expectations from established theory. Its makeup aligned closely with those of comets within our solar system. The release of gases adhered to conventional patterns, and its path displayed zero irregularities. Borisov illustrated how the majority of such cosmic travelers from afar would likely appear mundane, thereby heightening the fascination surrounding the evident oddities of 3 Atlas. The persistent debate surrounding interstellar meteors introduced further intricacies into the evaluation. That 2014 event, labeled the IM-1 Fireball, earned its status as a possible interstellar object thanks to its exceptional speed and atypical path. The recovery mission led by Dr. R.V. Lobb at the crash location yielded round fragments whose makeup led certain experts to propose an engineered source. Yet the IM-1 spherules continued to spark division. Alternative views held that such atypical makeups might stem from earthly pollutants or routine meteor behaviors amid intense pressures. Demands for bigger specimens and unbiased lab reviews had delayed strides toward firm judgments. Such prior encounters shaped the scrutiny of 3I Atlas information. Each irregularity demanded several separate verifications. All atypical readings had to be replicated via varied tools and evaluation methods. Experts across the field resolved to sidestep both mistaken detections and overlooked realities. Assertions of otherworldly encounters that ultimately fell apart, or rejections of real events born from overzealous doubt. Routine checks for biases turned into standard steps in the review workflow. Groups of specialists swapped datasets and task forces, hunting for pattern flaws or hidden biases that could distort findings. Rival partnerships united researchers, holding starkly opposing views on the evidence, compelling them to pinpoint data points capable of separating rival theories. Though the approach dragged on and occasionally irritated, it yielded results. Half a year following the close approach, an initial agreement began to form among scientists. Signs pointing to engineered beginnings seemed promising yet shy of decisive. A handful of central findings still eluded natural accounting, though rare cosmic events remained a viable option. Wording for outreach to the public stayed precisely tuned in the meantime. 3 Atlas displays traits tough to attribute to known natural workings. Although engineered beginnings stay on the table, additional sightings and reviews must precede any final verdict. Still, such measured words held deep weight. Humanities researchers, for the very first time, grappled earnestly with the chance of brushing against devices from distant societies. The evidentiary bar loomed immense, yet the prospective breakthrough merited the toughest probe our species could assemble. The thin line separating evidence from illusion stayed keen. Yet, through every fresh review, every separate validation, every unsuccessful effort to dismantle the peculiarities, the scales tipped gradually toward an outcome that would upend all our views on humanity's cosmic standing. Part 10. The message unfolds, content, form, and meaning. What 3 Atlas was trying to tell us became clear only through months of painstaking analysis, and that the transmission turned out to be far more intricate and utilitarian than observers had anticipated. Far from serving as a welcome or a contemplative declaration, it functioned as a comprehensive guidebook. Leading the global effort to unravel it was Dr. Yuki Tanaka from the Tokyo Institute of Technology, whose expertise in information theory and signal processing positioned her ideally to dissect the multifaceted nature of the extraterrestrial signals. What at first seemed like straightforward sequences of prime numbers emerged as introductory segments for intricate data bundles, each expanding on the foundational mathematical ideas from prior segments. The initial stratum laid down essential mathematical principles, creating common ground to enable advanced exchanges. Primes transitioned into algebraic connections, followed by geometric axioms. The extraterrestrial entity was imparting its own mathematical framework prior to delving into weightier notions. The next stratum brought in key physical values, such as the fine structure constant, Planck's constant, and the speed of light. Yet these went beyond mere affirmations of shared scientific truths. They arrived with exactness surpassing human capabilities, implying that the extraterrestrials held a superior grasp of core physical laws. It was the subsequent stratum that truly captivated, as the entity started relaying what amounted to engineering blueprints, step-by-step directives for building a radio transmitter array surpassing earthly advancements. These blueprints showed thoughtful adaptation to human constraints. Instead of presuming boundless supplies or cutting-edge substances, the blueprint relied on methods feasible for 21st-century terrestrial innovation. The array demanded a vast setup of synchronized emitters, though each part fell within the grasp of human ingenuity. Even more striking, the blueprint incorporated adjustments tailored to Earth's unique rotational cycle and geomagnetic traits. This was no off-the-shelf plan. It had been fine-tuned for our planet, indicating that the extraterrestrials had thoroughly examined Earth's attributes prior to outreach. The ensuing stratum featured what Dr. Sarah Kim of MIT labeled the connectivity diagram, outlining the integration of the suggested array into an apparent interstellar relay framework. The diagram depicted intermediary stations placed at key points across nearby cosmic expanses. Each station was defined by exact celestial positions, certain positions aligned with familiar stellar bodies. Others indicated void areas in the cosmos where gravity's bending could concentrate and boost transmissions over vast star-spanning gaps. The entity was outlining a messaging web that leveraged the Milky Way's inherent architecture as its backbone. Woven into the engineering details was an ethical component that demonstrated deep insight into life-bearing realms. The transmission incorporated icons and ideas unmistakably linked to organic entities, world ecosystems, and principles akin to preservation ethics. It carried subtle cautions regarding the preservation of low electromagnetic noise around vital biospheres, along with recommendations to site potent emitters distant from populated planets. The very method of encoding stood as a triumph in information science. Every data bundle featured redundant safeguards against errors, guaranteeing reconstruction even amid substantial damage or gaps. Sequential framing permitted proper reassembly of the broadcast regardless of breaks, frequency drifts, or sporadic sightings of the mobile source. Clear indicators specified data sequencing, measurement scales, and positional frameworks, averting confusions that might occur when civilizations with divergent numerical heritages sought dialogue. The message crafted for deciphering by any perceptive mind able to sense it, irrespective of the unique trajectory and tech evolution they followed. Yet the truly captivating element lay in the absences within the transmission. Absent were any intimate dialogues, any relics of society, any bids for casual banter or deep musings. The extraterrestrial dispatch stood as starkly utilitarian, serving as a blueprint for integrating into a seemingly long-standing cosmic linkage grid. The ramifications proved breathtaking. Our species wasn't merely fielding an inaugural signal from an alien society. Instead, an offer extended to align with a collective of minds that had functioned throughout the cosmos for some indeterminate span. Involving the masses in unraveling the code had yielded priceless benefits. Online crowdsourcing hubs enabled multitudes of enthusiasts to lend expertise to varied facets of the breakdown. Duties in spotting motifs went out to pupils in schools everywhere. This joint endeavor marked the grandest unified mental trial ever mounted by humankind. Matching renditions surfaced when separate groups, laboring solo, arrived at parallel understandings of vital segments in the signal. Such duplication lent assurance that the unraveling advanced accurately, even amid the wholly novel character of the exchange. The trial run of far-flung light-based messaging on the Psyche voyage had supplied vital know-how in handling vast throughput light transmissions over vast solar system gaps. Insights from that shaped guesses on advancing the alien dialogue past basic wave broadcasts to a richer info sharing. Still, the paramount feature of the dispatch might have been its hidden cutoff. The blueprint details for the signal tower encompassed time markers, exact schedules for startup and alignment with the wider web. Should our kind aim to enter the stellar collective, A narrow slot existed to erect and fire up our link point. The crossroads loomed ever nearer. The outsider had supplied thorough guidelines for assembling our personal star-spanning relay setup. The know-how posed a tough but doable hurdle. The core issue boiled down to if our species felt prepared to declare its existence to any society as potentially attuned across the stars. Erecting the tower would prove unendurable. After ignition, our planet's role in the cosmic web would endure forever, detectable by any awareness scanning the relay paths. No more a lone orb yelling into the void. We would merge into an immense, timeless expanse far exceeding our present grasp. In the end, the dilemma distilled to basics. Stay solitary or step into the discourse unfolding between celestial bodies long prior to our own societal dawn. Part 11: Second-Order Effects, Technology, Law, and Power. As soon as our kind gave real thought to erecting a star-reaching signal tower, the entire landscape shifted. Beyond mere tech advances, shifts rippled through governance, finances, and our very notion of human essence. Global design squads kicked off swift mock-ups of the methods outlined in 3i Atlas's dispatch. The tower blueprint strained the limits of our fabrication skills, yet stayed within reach. Razor-fine metamatter, tuned with pinpoint control at the nanoscale, would shape the core sending parts. Low-noise oscillators synced to atomic clock benchmarks would deliver the steady anchors essential for pan-galactic linkage. The toughest demand centered on harmony. The tower would comprise myriad solo broadcasters spread over hundreds of kilometers, all pulsing in flawless unison. The clockwork exactness called for nanosecond fidelity held firm across solar system expanses, insisting progress in quantum chronometry and decentralized management architectures marked significant milestones. Hybrid radar-laser collaborative setup surfaced as an essential innovation. Merging electromagnetic waves with meticulously synchronized light bursts enabled the signal device to meet the capacity and intensity demands outlined by the extraterrestrial directives. This bimodal strategy ensured backup capabilities as well. Should one component break down, the alternative could sustain the link. Yet each advancement in signaling apparatus brought along potential for misuse in other domains. Those exact synchronization mechanisms vital for cosmic outreach might steer long-range projectiles with extraordinary precision. Potent broadcast grids risked disrupting orbital assets or functioning as focused beam armaments. Supporters of global safeguards pushed for open oversight measures permitting worldwide scrutiny of the device's assembly and functionality. The capabilities proved far too potent for clandestine progress. Entities constructing such cosmic linkage tools would face mandatory audits and confirmation processes. Regulatory structures labored to align with evolving tech landscapes. The Outer Space Treaty of 1967 regulated orbital endeavors, yet remained silent on dialogues with off-world intelligences. The 1972 Liability Convention covered harms from celestial hardware, but failed to foresee conflicts over cosmic dispatch privileges. Draft laws started appearing from jurists across the globe. Proposed accords on encounter management, slated for UN endorsement, aimed to set global standards for alien interactions. These structures drew extensively from current disarmament pacts and ecological safeguards, tailored to the distinct demands of stellar negotiations. The matter of Earth's collective voice transcended mere abstraction. Armed with the alien signal blueprints, various countries and groups asserted rights to erect and manage our link in the universal web. NASA suggested a multinational alliance akin to the International Space Station collaboration. China revealed intentions for a standalone signaling array. Corporate entities offered their bids, contending that market rivalry would hasten progress. Access to information turned into a pivotal concern. Would the device's emissions qualify as shared knowledge for all people, or might the builder states or firms dictate entry to these far-reaching exchanges? The model set by our initial signal outpost would probably shape interstellar protocols for eras to come. Financial repercussions swept across industries. Scarce minerals needed for the setup drove surges in raw material costs lasting months. Lithium, already key for power cells, gained heightened importance as specialists recognized its role in quantum oscillation benchmarks. Yet the profoundest fiscal transformation was perceptual. Planning cycles stretched beyond fiscal periods and annual cycles into generations and millennia. Firms initiated strategies for prospects that could unfold only when descendants were at the helm of enterprises. This vast outlook reshaped human notions of duration and worth. Digital currency arenas birthed countless stellar tokens tailored for cross-system trade. Many blatant frauds, though others embodied earnest efforts to devise exchange methods bridging interspecies divides. The algorithmic needs for pan-galactic agreement drove distributed ledger innovations into uncharted realms. Spiritual and intellectual bodies wrestled with our evolving place. Could divine likeness hold if we cohabited the cosmos with fellow minds? Did responsibilities now stretch toward societies unfamiliar to us, ones we could soon align with? Religious training centers started providing classes on cosmic morality and dialogue across species. Learning institutions saw a surge like never before in enrollments for studies in physics, math, and engineering. Learners previously indifferent to scientific fields abruptly sought knowledge of the principles underlying contact across the stars. Local higher education outlets introduced sessions on understanding signal devices, covering the fundamental ideas essential for engaging in our species' dialogue with the cosmos. Ecological factors added layers of complexity to the design of signal setups. Broadcasting setups demanded vast quantities of energy, possibly reaching gigawatts of maximum use. Sourcing power with climate sensitivity turned crucial to prevent aggravating planetary warming issues, even as we aimed skyward. Investments flowed anew into sun-powered fields and nuclear fusion plants, with conservationists partnering alongside proponents of extraterrestrial outreach. Concerns arose over land-based broadcasting gear and its potential influence on animal life through magnetic waves. Creatures like avian species, marine mammals, and others relying on the planet's geomagnetic lines for orientation risked disturbance from intense signal bursts. Selecting optimal locations and devising emission guidelines proved vital to reduce harm to natural habitats. The Cis-Luna area emerged as the latest edge for advancing signal technology among humans. The moon's hidden side provided inherent protection against terrestrial noise for radio waves, positioning it perfectly for delicate detection tools. Asteroids close to our planet offered resources for building without the ecological toll of surface extraction here. Orbital pathway oversight, already pressured by growing business ventures, confronted fresh hurdles from signal-linked facilities. Debris in space from building efforts posed dangers to operational orbiters. Signal clashes between these networks and standard vessels in space called for precise allocation of wave bands. Worldwide teamwork arose as an imperative and a chance alike. Not one country held every asset required for swift assembly of signal structures. Effective initiatives demanded exchange of innovations, financial support, and specialized knowledge beyond usual geopolitical lines. The signal device acted as a spark for the sort of worldwide unity that had dodged us in earthly matters alone. Yet unity brought hazards. Joint signal operations required oversight mechanisms resilient to shifts in politics and global tensions. What if involved countries clashed over the substance of transmissions or their order? In what way could our kind settle arguments when outcomes might sway our role amid a stellar network? The organizational models created for managing these signals would probably guide our path in cosmic expansion for ages. The models set forth transparency against concealment, rivalry against partnership, state agendas against collective good, would affect pursuits from resource gathering on rocks to voyages beyond our system. With building schedules tightening and departure moments nearing, our species realized it was reshaping not merely its tools, but its very essence. We had ceased being a lone group calling out to emptiness. Instead, we geared up to enter as members of a vast interstellar society, its full extent just starting to dawn on us. The ramifications reached well past the signal alone, all facets of our communal life, spanning learning and commerce to authority and thought, adjusted to the truth of coexisting in the cosmos with minds potentially surpassing ours in power. The ripple impacts of encounter were remolding our entire way of life. Part 12. After the Echo, Who We Choose to Be. 2 years following the initial wireless interaction with 3 Atlas, our kind arrived at a pivotal juncture this choice would shape the destiny of humankind for countless generations. In the beginning of 2027, the extraterrestrial entity had exited our star system, speeding away on its curved path to obscure realms. Yet, its transmission lingered, stored within our digital archives and shared human recollection, serving as a guide to integrating into an interstellar society beyond our wildest conceptions. The option facing us appeared straightforward at first glance: erect the signal tower or stay hushed. However, the ramifications of either option permeated all facets of our societal framework. Policy debates in global centers of power and scholarly circles revolved around 3 primary options. The restrained strategy emphasized sustaining observation stations and enhancing our non-intrusive search for extraterrestrial intelligence efforts, while steering clear of any outgoing signals that could draw undesired scrutiny. Advocates contended that it would take generations or eons to grasp the interstellar society more thoroughly prior to declaring our existence. It made sense to watch from the shadows, gaining insights into prospective cosmic companions before exposing our position and strengths. Such a method held clear attractions. It offered security, the possibility of reversal, and permitted our species to evolve according to its natural pace. Our progress and innovation could proceed, our reach could extend across the local star system, and we could solidify the financial and cultural bases essential for interacting with superior societies on equal footing instead of as dependents. Yet, detractors highlighted the drawbacks of seclusion. The signal tower designs, supplied by 3 Atlas, embodied advancements hundreds of years beyond our current level. Declining involvement could stall our progress forever, dooming us to lag eternally after societies that had long exchanged signals across the stars. The involvement-oriented route suggested constructing a restrained, precisely managed signal setup that humanity could turn on or off through unified deliberation. This balanced option would demonstrate our readiness to connect to the cosmic web without rushing into ongoing engagement. The engineering demands were substantial, yet within reach. An array of spread-out broadcasters synchronized via quantum synchronization mechanisms and placed in orbit to prevent disruption to our planet's ecosystems. The signal would function at low energy outputs at the outset, signaling our location without flooding adjacent relay points with novice broadcasts. Oversight mechanisms would guarantee that no one country or group dominated our species' interstellar representation. The substance of messages would demand global consensus via broadened United Nations protocols. Broadcast timetables would harmonize research pursuits with prudent diplomacy. The bold route demanded total dedication to cosmic dialogue inside 10 years. Supporters maintained that the extraterrestrial entity's signal tower details incorporated urgent alignment needs. For our kind to integrate smoothly into the interstellar web, swift action was essential while the entity's transmission stayed timely and pertinent. This strategy offered swift leaps in innovation and prompt entry to any wisdom the interstellar society chose to offer. Initial involvement in cosmic exchanges could grant our species scholarly and inventive edges capable of addressing our gravest issues, such as global warming, scarcity of resources, and the hurdles of venturing past our home world. However, the dangers were immense. Complete immersion in interstellar exchanges would render our planet eternally detectable to any entities scanning the web. We would bind ourselves to alliances and duties beyond our comprehension. Exiting the web after entry could turn out unfeasible or provoke dire repercussions. The contention cut across conventional ideological lines. Forward-thinking ecologists discovered common ground with traditional defense experts in supporting the prudent strategy. Advocates of libertarian tech principles joined forces with global envoys to back a cautious strategy of involvement. The expansive view from space had thoroughly disrupted traditional alignments in politics. Sentiment among the populace stayed split yet attentive. Surveys repeatedly indicated broad backing for erecting some kind of signal device, though opinions fluctuated widely depending on the details of plans and their rollout schedules. The favored strategy merged aspects from each of the trio of options, rapidly assembling the signaling infrastructure while introducing it step by step, backed by robust protections and global supervision. What started as the Galileo initiative to hunt for evidence of alien tech grew into an ongoing effort to spot and examine technological signals from beyond. Its broadened scope encompassed watching for more cosmic travelers, scrutinizing the signal blueprint supplied by 3I Atlas, and laying the groundwork in science for potential encounters ahead. Sources of financing arose from surprising quarters. Wealthy innovators in technology, once fixated on satellite projects near our planet, shifted their capital to efforts in reaching out across the stars. Countries without prior involvement in cosmic endeavors started adding to alliances focused on creating these signals. Because the needed tech could be spread out, even modest nations found ways to contribute substantially via targeted production or studies. Rules and regulations kept developing via talks on the world stage. Limits in the Outer Space Treaty against claiming heavenly objects for one country got broadened to include nodes for talking across the stars. Fresh guidelines managed how to divide up extraterrestrial tech and spread out gains from joining the wider cosmic network. Deciding who would oversee institutions turned into a key issue. Signaling setups meant to function over hundreds of years demanded oversight bodies able to endure shifts in power, financial crises, and shifts in society. The example set in keeping things steady over lifetimes would decide if people could count as a dependable part of any star-spanning society. Efforts in science sped up no matter what policies were set. Dishes for radio waves kept scanning for more arrivals and trying to pick up the larger web of star communications outlined in 3I Atlas's message. Tests with bending light by gravity checked if lines focused through stars could truly boost transmissions over vast gaps between systems, just as the arrivals had outlined. Early versions of signal parts got tried out in orbits around Earth and at stable spots near the Moon. Human cleverness was overcoming the tough hurdles in tech, yet the schedule for building stayed daunting. Achieving complete signaling power would demand no less than 10 years of steady work, likely more. Systems for mental health support appeared to aid people and groups in adjusting to the grand scale of existence. Counseling for encounters turned into an established field, assisting folks in absorbing the fact that our kind belonged to a bigger society among the stars. Gatherings for mutual aid sprang up naturally, uniting those wrestling with purpose and direction in an abruptly immense cosmos. School programs shifted to ready young minds for what could involve everyday exchanges with distant worlds. Kids reaching adulthood in the 2030s and 2040s started studying numbers and forces with a clear awareness that such skills might serve in dialogues with otherworldly minds. The gap between age groups stood out sharply. Elders frequently grappled with what contact meant. As the years advanced, the decision facing humankind, the debate coalesced on a core dilemma of selfhood. Would our essence lie in venturing forth as pioneers or in safeguarding our legacy as custodians? Would our character emerge from bold forays into the uncharted or from steadfast guardianship of our hard-won gains? When the resolution arrived, it embodied elements of each drive. Our kind would erect the signal tower, yet with utmost prudence. We would integrate into the stellar collective, yet under conditions safeguarding our independence and shielding our native planet. This middle path pleased neither the boldest visionaries nor the sternest skeptics, yet it captured a broad agreement across our race on the identity we aspired to forge. The evening heavens appeared transformed. Those specks of radiance, previously remote and barren, now stood as likely abodes for sentient beings whose signals could already be racing Earth's way at light's pace. The universe had shifted into a sprawling district, immense past all grasp, yet brimming with presence. Ultimately, that might have been 3 Atlas's profoundest offering. Not the means to enter a cosmic society, but the realization that isolation had never defined us. Amid the celestial expanse, kindred intellects pondered identical riddles, confronted parallel trials, and stretched toward those far-off gleams that had fueled mortal aspirations from our earliest awestruck gazes skyward. The exchange, sparked by our unintended broadcast emissions and advanced by 3i Atlas's deliberate reply, stretched well beyond conclusion. Indeed, it stood at its dawn. The true puzzle lay not in our entry to the stellar fellowship, but in the caliber of companions we elected to embody. With our planet's inaugural cosmic transmitter activating for its debut broadcast trial, a subtle, steady hum ascended across fundamental numeric bands. These marked our race's premier deliberate utterance in a dialogue poised for us eons prior to our mastery of speech.